Yeah, so for those of you who don't know me, my name's Brendan. Just in case you didn't quite get the minute, this is going to be a bit of a tongue-in-cheek talk about this stuff, because ultimately lots of things that are academic are kind of very dry, so I kind of wanted to spice it up. For those of you who don't know me, Nick was supposed to be here last night, so I was going to give him rubbish for this. Yes, I do more than just hand out stickers for GitHub. I'm on the Windows team, and so we have a whole bunch of basic initiatives around getting GitHub and .NET devs and the Windows ecosystem to play nice. And so I'm going to do a talk on three parts to this. Does anyone here do desktop dev or mobile dev or that? Fantastic. So you know what MVVM is in terms of that, wicked. So I'm going to do some stuff that I don't like about MVVM. Then I'm going to talk about functional reactive programming, as in like how it came to be and what stuff's good about it. It's only been around since like 97 was one of the first papers. So it's a very young sort of field, but there's still a lot of stuff in there that's of interest. And then, of course, I'll dive into Reactive UI and show how you can do the stuff that we learned about in the previous section. So, MVVM, there's three things I really don't like about it these days. And the first thing I'm going to talk about is interactions between components in your view models, essentially. So you have a property that updates here, you want to do something else. I'm going to pick on a former colleague, Mr. Cowitz. He's got a property on his view model here that is essentially called has members. It implements unnotified property change, which is fine, I'll leave that for now. But behind the scenes, he's got this little guy here, depends on. And inside the get, he's doing some checks there if it's null.
It's string, so it's not string type.
Yep, so this little, so stringly type too, but that little depends on attribute there is essentially going to inject some other code back in the other property. You know, a little bit of magic behind the scenes to do less code, but it's really hard to follow as someone else looking at that code. Coming back to the next things, asynchronous stuff. Back when WPF came out, what year was that? That would have been like 2008. They didn't even think, they didn't even have task parallel library support. But of course, you'll still happily write code like this in your apps. These methods here will return void. I'll get to that in a moment, but in particular, that stuff is really, really hard to test because it's essentially fire and forget. You might be thinking at this point, sure, async await has come around. That's, you know, we can use that right now. It's not that great for this stuff. There's a paper that was put out recently by some college students in the US and in the Netherlands. They did a sample on a whole bunch of open source apps. Of course, feel free to make your own joke about open source Windows Phone apps in terms of that. But they actually had a really good sample of 3,000 devs and 12 million lines of code. And they looked at the stuff that they were doing around task parallel library and async await. 1 in 7 scenarios came up where they didn't actually need to use async await. They could just return a task. 20% of apps missed opportunities to be more asyncy. And this one's my favorite. Configure await if you ever had to deal with tasks. When you call await on a task, it'll actually capture the context of the request, and when it comes back, you will then be back in the same context, which is great for UI threads, but quite often, or most of the time, you don't need to. So yeah, 99%. Like, I'm fairly certain I've messed this up as well. So I'm not a huge fan of async await. We used it a bunch in GitHub for Windows, but we're gradually pulling that stuff out and just using pure RX. Bindings. I'm just going to prepare yourself. Bindings, in terms of the stuff that we use with XAML these days, are essentially just reflection. And they're expensive to test, actually validate, and they're expensive to recompute when things change under the hood. Coming back to some stuff that Mr. Couch wrote, notice all these squigglies. This is ReSharper saying, I don't know what the hell this property is, I hope you do. And it gets worse as you go further down. You can nest the stuff forever, and ultimately at runtime it'll go, oops, I don't know what this thing is. I'm just going to tell you somewhere in Visual Studio, and hopefully you notice this. So yeah, this stuff here, particularly on mobile platforms and things like that, really hurts. So Microsoft will literally say, do the stuff in code behind, don't do it over here because reflection is expensive. All right, so that's my little rant over. Let's move on. Functional reactive programming, the stuff we're actually here to talk about. Oops, I jumped forward a bit. 1997, Winamp. Who remembers Winamp? Yeah! So a couple of months after Winamp came out, ICF... they're not related. I just wanted to put people's time relative to... So no, these two guys, Conal and Paul, put a paper out at ICFP. Have you heard about this conference at all? Big one for functional programmers. It happened to be like 10 years later, they got awarded the most influential paper for this year. And what they were proposing was a language that was, a DSL that was built on top of Haskell to represent things that were done around animations. And they teased out a whole bunch of concepts that basically drove what the FRP sort of space did for the next 10 years. So the three things that are interesting from that paper was they had this thing called behaviors. So if you imagine you've got a value, you create like x equals 1. What if you had a value that you could change over time and you could then do stuff with? So that's essentially what a behavior is. I'm not a huge fan of the name itself because it feels so very vague, and others have decided to call it signals. So signals makes a lot more sense in terms of this thing's going to notify me when things change. And so that's kind of become the name, the default name for this thing rather than behaviors. The next thing is events. We all know events in terms of imperative programming. You listen to an event and do some stuff with it. They made the stuff first class. So you could then basically create an event, pass it into your system, and do some stuff with it. It could both be external stuff, but you could also do events inside your app. And the third one is lifting. This one is very popular amongst FRP people, but it's basically a way to bring a static function and apply it to a signal. So here's a little example. Time is our signal here. Notice how we haven't actually defined what time is. We just know there's going to be a continuous stream of events from here until the heat death of the sun. That's it. And then we've got sine, which is our function. So wiggle is lifted, sine, so this is the actual Haskell sample. It's just basically a way to implicitly lift the signal onto a signal. We can then take our first signal and then build that stuff up. This here is just going to be signals from 0 to 1, up and down. We now have then a range, and ultimately what we're building up, a red ball that goes bigger and smaller, and we draw it red. So this is actually part of their paper, and they showed how you could build this stuff up using behaviors and events. Go a little bit further, we then pull in time again as a signal, and we have a bigger function there. We're composing this stuff together as functions, but then we also have events which we define as late as possible. That's a quick sample of what the events look like from the paper. We have a mouse. As you're moving this thing around, it represents a signal of events. We pass it in a shape, and the function will move the shape around. But there were two things that came up from this paper that were very interesting. The first one is how push and pull work from events. So if you think of like the classic collection where you're pulling stuff out, that's what they call demand-driven sampling. The flip side of that is the push collection. So as this thing has data available, you get stuff computed, or you get stuff sent down to you. So if you imagine coming back to this sample here, we haven't defined the scope on time, but we could do it like every sort of millisecond. That'd be reasonable enough for computing what we're doing, especially if it's like animations. But we could then ask it every second. If we're doing like, let's say, 60 hertz sort of screen, that becomes then our scope. We could then pull stuff in at 60 hertz, or we could make time come out at 1/60th of a second. The stuff that was rather interesting is they picked up on two different sorts of signals that came up. So continuous is a great example is time, or discrete, which is like mouse clicks. So which way you kind of get stuck with a situation of things that are expensive to compute, like time. You want to kind of do that stuff as you need it, but then discrete signals like your mouse clicks, they're easy to kind of compute as they come through. So these things are getting teased out of this paper, and if we fast forward a little bit further to 2012, Evan, who's been working on this framework for a few years called Elm, he took a brief summary of all the stuff that's been happening in FRP since. So 1997, we had classical FRP. We go forward a few years to sort of real time, where they were like dealing with essentially all the limits that came up in the first implementation. They wanted to kind of improve performance, that sort of stuff. And then they kind of realized they went too far, and so there was a bit more about event-driven. So kind of that's how this thing evolved, and arrow-ized FRP is kind of what's popular at the moment, and it's kind of it's balancing essentially real-time and event-driven to kind of make sure that things are performant, but as close to real-time as possible. The example that I'm going to show you guys in Elm is a clock, and that's the whole code. So remember how I was talking about things being aliased? So we have a function here called clock. We then essentially lift this signal up here, And every second is just basically an A-list version of time. We then go further down here and we say, hey, we've got our hands being drawn up, and the rest of it is essentially very much functional-less code. We've got a collage here, which is a certain space, and we have a number of shapes inside it. Very succinct code, and there's a couple of little A-lists and things in here like that. And that's the whole function. So, no, I won't go off track. I'll show you that site later, but there's a whole bunch of examples, because this language here compiles down to JavaScript. And what Evan has been working on, do you know Prezi, the presentation tool? They're using Elm to do this stuff. All right, so I've gone way off the track. Let's come back to .NET. Reactive extensions, there's lots of talks out there about reactive extensions. I'm not going to go into them again, but I'm just going to show you the stuff that's relevant to reactive UI. So we have two interfaces, iObservable and iObserver. Ignore iObserver, we're just going to do iObservable for this part. In terms of the lifetime of an iObservable, you'll have a number of events that get raised. Could be 0, could be any number, and then it'll either complete or it'll error. That's the lifetime of it. If you're thinking about tasks, that's the equivalent of having a task that returns you nothing, is our lovely unit of an observable, and then task of T is like equivalent to observable T. These guys return you one result, these guys here could return you nothing, or you get a number of results. And so to subscribe to the observable and get some results out, that's essentially all the code you'd use. You build it up, you have sort of then your completed or your error callbacks, fairly straightforward stuff. You could also then plug in and say, if something goes wrong, I want you to return something else, and then you kind of kill off your error handling. It's a lot better than task parallel libraries, I believe, in terms of that sort of stuff, in terms of control flow, but your mileage may vary. The other part that's relevant to reactive UI is the concept of schedulers, where code runs. So behind the scenes, if I want to put some stuff on the main thread, I just say observe on the dispatcher scheduler. Then I can do some stuff in here, I'll be on the right thread, and I can update my UI. If I want to do something more complicated, I have my background thread where I do the task on, I bring it back to the main thread, and I update my UI the same. You get a lot of control about where things run, because literally you're just wrapping an observable in another operation, and you pass it through. And if you love Link, you will love reactive extensions, because all these operators that you're familiar with have also come across. What's a really good one? There's some extra ones on top, being able to combine two observables together and get a sequence, essentially, and then I can mash them together to say, just give me even numbers. That stuff's really great. It's really easy to do. Oops. Distinct until changed is a great way to prevent over-computating the signals that come through. My subscriber will then only get things that change. And coming back to this whole signals that get overly computed, there's a thing in RX where you have sort of two different signals. There's no actual defined behavior for what an observable does when there's no subscribers. By default, I believe it should do this. So if you've got nothing happening, you shouldn't, or if you've got nothing listening to you, you shouldn't be sending anything. But sometimes you'll hit these things called hot observables, where they'll just fire things off even though no one's subscribing. Just a thing to watch for. It's bitten me a few times, and you just go, oh, it's a hot one. All right, so we're now into reactive UI, the fun stuff. Before I do this, I kind of want to share some notes from a colleague of mine to say, what does an FRP codebase actually look like? We want to have things as immutable as possible, because immutable things are more easy to reason about. They're more easy to essentially test, because once you put the thing into the right state, it should be there. But then you have these signals, which should represent things that change. And so ideally, you should have the stuff signals in and signals between components, and everything else should be immutable. I'm not prescribing you use MVVM. Like if you've got another architecture pattern in your app, that's great. Again, I'm just using this stuff because that's how we roll. Readability is something that actually goes up really significantly when you're doing the stuff, is what I've found. All the stuff that you define in terms of all your signals and that define your constructor. So we have one place to do the stuff, then you just have a whole bunch of other properties behind the scenes which represents your actual view model. I'll show you some examples of what this stuff looks like before, but it's, yeah, I really enjoy it. So you know how I was talking about how MVVM and you have properties that come up? How do we do the actual bridging between an observable, like we had some events coming through before, and a property, which is essentially a static thing? That's one thing that RX UI does well. The base class for a reactive UI is this guy called Reactive Object. And so then we have extensions off this stuff to hook in and say, I'll show you the dev code. So this is an example from GitHub for Windows where you're selecting an account in the UI, we do some stuff, and essentially then we fire off a command. That's all the code. So we do some checks here. I think we could probably optimize this a bit. So if this stale value is actually true, we then go off and load the repositories for the current user. Imagine you're tabbing around in the UI and you don't want to basically reload it every time. We track those things as properties. When the properties change, we then go through and check that we actually should do something. Then we fire off a command. This is then where the property comes into it. If I'm doing a clone of a repository, I then have this guy here. So this when any is ultimately the guy that takes care of raising all the changes. So I can have a number of expressions like here. I had two of them. I then combine them together. Actually, I forgot away this style, but that's that. So then the when any becomes an observable that I can then play around with like any other sort of observable. So my when any here, I have a progress value, which is just like a stream of integers. I then just pass on the value, and then I map this to a property. So progress is this guy here, observable is property helper, and then I just expose that as an empty getter. No setting logic at all, just firing up and doing the transform from an observable to an int. The next part to this jigsaw is the reactive command. So you remember how I was talking about things that weren't async? Reactive command is our thing that builds on top of iCommand. And these are all the different ways you can set up reactive command. Just a plain old one, fire and forget, filtering on when you've, the can execute scenario, and our asynchronous operations. So if you've got a task that does something, you can just wrap it in a command and you'll know when it's done. That takes away all the fire and forget stuff that you deal with when you're dealing with that command. And like before, if I've got a plain old command, when I want to hook into it, I just subscribe to it. This makes testing really, really great. So I can just await. So you know about how tasks and observables can interop? I'll show you some of this stuff later. But basically, you can await on anything in .NET as long as you provide the right sort of interface. It's a bit like duck typing, essentially, but I can explain this a bit later. So iObservable here, reactive extension ships essentially an awaiter for the stuff. So the keyword picks it up, it goes, oh, you're in this assembly here, you've got this certain method, I'm going to do the transform for you, and it knows that it can wait on that. Is that a question or no? You also get exceptions. So if something goes wrong in your long-running task, it doesn't bubble up to your app, it comes through here. And like before, it's observable. It's an observable. So you just subscribe to it, log out your errors, and move on with your life. And who's ever done a refreshing animation, or is a loading animation on your page? This is all the code you need to write to do it. So my command here refreshes. There's this property here, it's executing. That's an observable of Boolean, true or false. As your command goes up, goes, oh, it's true. You then map that to a property, and you're done. That's it. It's so good. And unlike before, my observable property helper is there. I then just back that up, and yeah. And the last part, view bindings. So in the beginning, or in the early days of Reactive UI, we didn't even think about the mono stuff. We then got to a point around version 4 where we were like, all right, we've got to do something about this. And so I was actually involved with some of the design around this stuff. But basically, we wanted to kind of support these platforms in a way that was, consistent. So this is how you would light up just a XAML view to use the Reactive UI bindings. You throw on this interface here, view4, you put your view model in there. So this plays nice with data context, so you don't need to kind of drop one or the other, you can kind of use both. But all you do inside your constructor is call this .bind. So that's the way to map a text box to a name. Type safety, it's done. Looks very much like all the other stuff for doing Reactive UI. One-way binding for doing that stuff is also in the box. Mapping to dependency properties, so you don't need to do the converters as well. There'll be a whole bunch of implicit stuff that's built into the box, and if it doesn't know how to do it, it'll just blow up at runtime.
So in your example, you just have your text box with your controls names,
Mm-hmm.
and you just so there's no binding expressions, you just do it all in the code.
Mm-hmm. Yep. Yeah, so that's the control named refresh, whatever icon we determined to use. And commanding is also there. yeah, like really terse stuff. I'll show you some stuff at the end of the talk. It won't be recorded, but yeah, that's not far off the actual code that we're running in the app. And advanced selectors I'm going to show you next. But yeah, so all this stuff is no longer dependent on reflection. When you change a property, the bindings get updated automatically. No need to have ReSharper installed. And that's a really advanced one. So your view can also tell you when these things change. I then group them up together. I can then essentially do this task, which is focus on an item in the list. When you're filtering an item and the selected item changes, yeah, again, binding similar to your view model are available in your view. All right, so the stuff that sucks about this. Coming back to Justin before, debugging reactive code is a lot trickier. I'm not going to mince words. You learn by experience, basically. And that said, like straightforward back traces.
You could say you could step with calls, which is look something from what get
was that a question or just a?
I mean, is there some way to respect with calls, like Rafale or something? So I just know what is execute.
There's a link somewhere on Paul's GitHub account, and there's actually there's yours for your talk. There's a plugin that shows the events, visualization of event streams.
Okay, that's something else. All right, so the question from the audience was, how do you measure how do you detect thread activity? Was that the one? So making sure that things are running on the main thread versus things that are running on background thread. There's a tool for Visual Studio that was on the Ultimate version but is now free in 2013. So I'll give you the links to that. So that's really great. You leave it running as part of your app, and you'll see over time you'll get like the CPU usage and all that stuff. And there's ways to hook in and say when its task is running, log a message. So you can kind of just visualize all that stuff. That's really great. But still, if you're using .NET 4, the stack trace is going to be awful. .NET 4.5 makes it better, but you still kind of lose that context jumping across threads. I can show you some stuff after to kind of make that stuff nicer. And of course, I'm into threads now. This doesn't kill off the need for doing multi-threaded programming. It gives you a bit more power. But yes, you can still shoot yourself in the foot. Yeah. So I've got a few people in the crowd who kind of use Reactive UI. Is there any questions they want to ask me?